Hello, in this video we're going to be answering the question, how can we graph parabolas? We have some vocabulary to discuss, and then we have three forms of a quadratic function that we will be practicing on how to graph from each form. First, some vocabulary. Our first word here, vertex, that talks about your turnaround point. So if your parabola opens down, it's the top. If the parabola opens up, it's the bottom. If it's the top, we call that vertex a maximum. If your vertex is the bottom, we actually call that vertex a minimum. Through the vertex, we have what is called an axis of symmetry. So we could fold our parabola in half, and what is on the left gets reflected onto the right. We could fold this parabola in half. What is on the left gets reflected over to the right. The equation for that axis of symmetry is x equals a number. That number is the x value of your vertex. We also have a y-intercept. For our y-intercept, it crosses through the y-axis, and the x value of the y-intercept is 0. The y value is where it crosses through your y-axis. We have x-intercepts, right? In this case, each parabola crosses through the graph twice. You could have this parabola be moved down to where the vertex is just touching the x-axis and we would only have one x-intercept, or we could move it down farther to where the parabola is not passing through the x-axis at all, and in that case we have no x-intercepts. For the x-intercepts, you read the x value and then the y value is always 0. We have these two words increasing and decreasing. When your parabola opens down, we are increasing until we hit the vertex. When the parabola opens up, we are increasing after the vertex, to the right of the vertex, we could say. Decreasing means it's going down from the left to the right. So if your parabola opens down from the vertex to the right, it's decreasing. If your parabola opens up, it's decreasing on the left side of the vertex. So again, if your parabola is opening down, it's increasing, then it's decreasing. The vertex is a maximum. If your parabola opens up, it's decreasing first, then it's increasing, and your vertex is a minimum. Let's talk about domain and range. First of all, the domain for any parabola is x equals all real numbers. And we notate that by this little double line with a capital R, and that is shorthand notation for all real numbers. Again, the domain for every parabola is all real numbers. The range depends on whether your parabola opens up or down. In this case, if it opens down, that is the largest value that y can ever equal. So we say that y is less than or equal to that y value from the vertex. Right there. If the parabola opens up, that y value is the lowest that the graph can have. So the range is going to be y is greater than or equal to that particular y value that we get from the vertex. Let's talk about the axis of symmetry. If we want to get the axis of symmetry from vertex form, we take x minus h and set it equal to 0. X equals h is your axis of symmetry. We use that axis of symmetry as the x value of your vertex. The y value of your vertex is simply k. From standard form, we can very easily find the y-intercept just by looking at this number out here. The number without the x, we call that a constant, and that is simply 0c. That is where the graph will cross through the y-axis. To get the axis of symmetry from standard form, we use this formula, x equals negative b over 2a, and I will provide you with an example of that in future slides. This last one, called the intercept form of a quadratic function, if we take what's inside the parentheses, just like before we took inside the parentheses x minus h and set it equal to 0, we take what's inside the parentheses x minus p and set it equal to 0, we get x equals p. P comma 0 is one place where this parabola will cross through the x-axis. Another place where it will cross through the x-axis is q comma 0. And again, we get that by setting x minus q, what's inside the parentheses, equal to 0. Okay, so let's do this first example together. We have f of x equals negative 16 times the quantity x minus 1, that quantity is squared, plus 32. So if we take and we read x we read h and k from this this function right here, we get that h is 1 and k is 32. We put that in our table and plot the point at 1, 32. We can work on either side of that. Let's go back to x is 0 because 0 is an easy number to do algebra with, right? We do f of 0 equals negative 16 times, instead of the x, we have 0 minus 1 squared plus 32. We simplify that using PEMDAS, and we get that f of 0 is 16. So we put 16 in our table, and we plot a point at 0, 16. Now keep in mind, the vertex passes through this axis of symmetry at x equals 1. So we can take this point that we just found at 0, 16 and reflect it equally onto the other side of our axis of symmetry to get another point in our table at 2, 16. We can keep going and find f of 3 right here by simply inserting 3 every place where you see an x, right? So negative 16 times the quantity 3 minus 1 squared plus 32. And when you PEMDAS that, we get that f of 3 is negative 32. So negative 32. Now, it would be easy to just think, oh, this is a straight line. I see a pattern here, and it's going to go through this point right here at 3, 0. But we just found out that it does not go through 3, 0. It goes through 3, negative 32. So not here, clear down here. And then we can take this point and reflect it to the other side of our axis of symmetry. And we get that negative 1, negative 32 is another point on our parabola. When we draw that parabola, right, make sure that it's not a V, it is rounded at the vertex, it's not pointed at the vertex. We see that on the left side of the vertex, it is increasing, and on the right side of the vertex, it is decreasing. Again, the domain is x is all real numbers, and the range is y is less than or equal to 32, and that 32 is the y value of the vertex that is the largest that y can ever be. For our next example, let's look at f of x equals 3x squared minus 12x plus 9. Okay, I am going to make sure and point out that a is 3, b is negative 12. You have to include the sign in front of the number, and c is 9. So my y-intercept at 0, c is 0, 9, and I can plot that point right here on the y-axis. Next, I'm going to find the axis of symmetry by using x equals negative b over 2a. So the negative sign in front is part of my formula. This negative 12 is because negative 12 comes from my function. And when we simplify that, we find out that x equals 2. So that x equals 2, that's the axis of symmetry, right? I can take this y-intercept and reflect it equally onto the other side of my axis of symmetry. I'm going to use that axis of symmetry x equals 2 and plug f of 2, so x is 2, I'm plugging 2 into my equation every place I see an x, equals 3 times 2 squared minus 12 times 2 plus 9. And when we PEMDAS that, right, we simplify all the way through, we get that f of 2 is negative 3. So we're going to put negative 3 in our table, plot our vertex at 2, negative 3. And then maybe I want to go between 0 and 2 and do f of x equals 1 as another point to help me graph my parabola. So I'm going to do f of 1 equals 3 times 1 squared minus 12 times 1 plus 9. And when we simplify that using PEMDAS, we get that f of 1 is 0. So that 0 goes here, and that 0 goes here. And then I can take this y-intercept and this x-intercept that I just found and reflect them to the other side of my axis of symmetry, right there and right there. I'm going to fill those into my table, 3, 0, and 4, 9, and draw the parabola. Again, on the left side of my parabola, I have to think about, is it increasing or decreasing? Or on the left side of my vertex, it is decreasing. When I hit the vertex, it turns around so that after the vertex to the right, it is increasing. The domain is x's, all real numbers. And the range, the bottommost value that y could ever equal is negative 3. So that means that y is greater than or equal to negative 3. For our next example, we have f of x equals negative x minus 4 times x plus 2. And that follows the same format as our intercept form of a quadratic function. So I'm going to take this x minus 4 inside the parentheses, set that equal to 0, and I find that x equals 4. So I'm putting that in my table. And then I'm going to do the same thing with the other quantity, x plus 2, set it equal to 0. I find that x is negative 2. I'm going to plot those 2 points on my graph, right here at negative 2 and right here at 4. The y value for each of those points, since it's on the x-axis, the y value is 0 for each of those points. And then my axis of symmetry, if I imagine folding this as a piece of paper, folding it in half, I would want this y-intercept to be on top of this y-intercept, and the fold line, I can kind of see it happening right here in the middle between those two numbers. So to find in the middle of those two numbers, I'm going to add p plus q divided by 2, right? P is 4, q is negative 2. When I add them and simplify, I get that x equals 1. So x equals 1 is my axis of symmetry. I can also put that 1 into my table halfway between the two x-intercepts that I found. I'm going to take that value of 1 and find f of 1 by replacing each x with 1. And then when we simplify, we find that f of 1 is 9. So I'm going to plot a point at 1, 9 as my vertex of my parabola. The vertex is on the axis of symmetry. And I'm going to fill in the 9 in my table. Then I'm going to go between my vertex and one of my x-intercepts. I think 0 is a nice number. It's very easy to put a 0 in for each x. And when we simplify that using PEMDAS, we get that f of 0 is 8. So 0, 8 is a point that I can plot. And I can reflect that point to the other side of my axis of symmetry. So the y value is 8. I come down here and read the x value is 2. I can put 2, 8 into my table. If I want to find another point to make sure that my parabola has a nice smooth curve, I could choose x is -1 and find f of -1 to be 5. And then I can reflect that point to the other side of my axis of symmetry. I'm going to draw the parabola nice and smooth. It's rounded at the vertex. And then I'm going to read that my vertex or my parabola is increasing on the left side of the vertex, the left side of the axis of symmetry. And then it's decreasing on the right side of my axis of symmetry. Again, the domain for parabolas is x's, all real numbers. And the range, in this case, I see that my highest y value is 9, so I'm never going to be greater than 9. I'm always going to be lower than 9 for the y. So the range is y is less than or equal to 9. Thank you for watching. I hope that you learned a great deal about graphing parabolas.